Hi everyone. Due to unforeseen circumstances, we could not complete last week's week one mentoring, so this is a recording of the slides. Please make sure to go through the entire thing. And now and for meteorology, your mentors are me, Krishay, and Arav. I'm Krishay, by the way. So, what is meteorology? Meteorology isn't the study of meteors of space, but in fact, the study of the Earth's atmosphere, the physical processes, and how these factors influence weather patterns and the climate. It's not as boring as it might sound right now, but as you continue researching, you'll love this event. Trust us. So, the most important thing in meteorology is note taking. This is because in meteorology, you're allowed a binder of any size. This means everyone will be essentially it's a competition of notes. How well you know your notes, how you can navigate through your notes, and also how much you're depending on your notes. So first, let's talk about the actual notes. So note taking is a very important skill in Science Olympiad and meteorology. Make sure for online research that you use articles and videos, and make sure to use as many sources to fact check each information you have. So a few researchers is the NOAA, National Oceanic Atmospheric Administration. It has almost everything you might need to know about meteorology and this year's topic, which is about climate. On top of it, use videos to grasp concepts on the surface level and interpret charts and diagrams. Last year, they were quite helpful to interpret many charts, such as radio sounds, etc. And this year in section 12, there's similar charts that you need to know about. So that'll be helpful. On top of it, the Slightly Wiki can be used as a baseline for all your notes, as it has the Slightly Wiki for meteorology. It has most of the topics for climate and has a brief summary. On top of that, other notes. Please do not plagiarize your notes off the internet, as we will be checking your notes. And if they're plagiarized or incorporate AI, you may be at the risk of expulsion from the team. And in general, copy pasting articles is not beneficial. In the competition, you won't understand the content fully. And lots of questions are short answers, so knowing the content can be really helpful, as it will help you save time and have that upper edge against other teams. So as we present the actual content, make sure to take notes. So the first thing we want you guys to do, if you haven't already, because Botzel's Invitational is quite soon. So we recommend you guys to create a Word document to keep your notes online on Word. It's much easier to format and edit notes throughout the competition season. So to start off, add the rules menu, screenshot it, and add it to the front of the note sheet. You can help it formatting your notes, gives you a general overview, and some of the answers on the test are often on the rules menu. You can on top after that, make sure to have a header and number your pages. And after that, you can make a table of contents that will help quite a lot with organization and to access all the notes. You can also use tabs for the binders, like physical tabs that can be used for organization, but the table of contents is actually quite helpful. Three, we have images. Images are key to meteorology because many of them are like identification based, especially last year, which is about severe storms. So make sure to have images about the topics for climate this year, as they can really help. So the rules manual. The rules manual is their study guide. Basically, everything on the test will be on the rules manual. Use it as a guideline for what you want to incorporate into your notes. You can split up your topics on it, but we recommend not splitting up sections that are crucial to knowing the foundation of meteorology for this year. So the link is here. We'll send the presentation and the link soon. But hopefully you already have access to this. So now everyone open up your Word document and create the doc and make sure to create notes. And we'll be going over two sections today: the difference between weather and climate and the composition of the atmosphere. So, weather v climate. So, what exactly is weather? Weather is the current atmospheric conditions at a certain time and place, including the current temperature, precipitation, wind, and cloud coverage. Climate, on the other hand, is the average weather pattern over a long period in a given area. It encompasses average temperatures, average precipitation, and other weather elements. If you didn't understand what it is, keep this one sentence in mind. Climate is what you expect to get, while weather is what you really get. Now let's talk about the atmosphere. The atmosphere has many layers: the troposphere, stratosphere, mesosphere, thermosphere, exosphere, with many pauses, like the tropopause above it, the stratopause above it, the mesopause, thermopause, etc. The atmosphere is a combination of gases that surround the Earth, and they have many usages. One is protection. It shields Earth from harmful radiation and celestial objects like meteorites. Two, temperature regulation. It traps heat to maintain a moderate temperature range, such as the greenhouse gas effect, which we'll talk about later. Three, weather contains moisture from weather. It contains moisture from the clouds, and it's where weather actually occurs. A fun fact: most weather occurs in the troposphere. The troposphere is where most clouds form and where most of precipitation and weather actually and clouds actually form. Air. As air, our atmosphere contains the air we breathe, which is mostly nitrogen, 78%, and oxygen, which is around 21%. After that's like 0.03% argon or something. Life. The atmosphere contains chemical and climatic conditions that allow life to exist on Earth. So, let's go through each of these 5 layers in depth. Make sure to keep notes. The troposphere is where we live currently. It contains most of our weather, and decreases with it has temperatures decreasing by 6.5 degrees per kilometer Celsius. This is also known as the environmental lapse rate, if you want to know the actual term for this number. It contains 75% of the air in the atmosphere, and the lower part is the boundary layer, while the upper part is the tropopause. So over here, this is the boundary layer, and the top is the tropopause, right about here. Second is the stratosphere. It contains much of the ozone in the atmosphere. Ozone essentially is O3, while what we breathe is O2. Oxygen 2, oxygen 3. I mean, not oxygen 2, oxygen, but O with the subscript 2, and ozone is O with the subscript 3. We'll talk about the ozone and ozone layer later, by the way. In the stratosphere, temperatures increase in height due to the ozone layer, and the upper limit is called this limit is called the stratopause. Then we have the mesosphere, which is the region above the stratosphere where temperature decreases with height, reaching negative 90 degrees Celsius at the mesopause. Mesopause, by the way, is over here. Finally, we have the thermosphere, which is the region where temperatures rise due to the absorption of radiation, such as UV or X rays, from space and the sun. At around 80 kilometers above, there is something known as the ionosphere, where solar radiation knocks electrons off of atoms to make them cations, or cations, which are basically molecules that have gained or lost electrons to have a charge. And in this sense, cations have lost electrons, and these absorb radio waves. Finally, there's exosphere, which is the region 500 kilometers above, containing oxygen and hydrogen atoms that rarely collide, following trajectories under gravitational pull and sometimes escaping into space. So this is an image of layers of Earth with elevation in miles and kilometers, as well as temperature. So as we talk about the main trends, where troposphere, it decreases at 6.5 degrees Celsius at the environmental lapse rate. And then in the stratosphere and thermosphere, we see 2 distinct patterns. While we would expect it to decrease with increasing altitudes, the temperature actually starts to increase. In the stratosphere, it's because of the ozone layer. And the thermosphere, it's because of UV and X-ray radiation absorption. In the mesosphere, it decreases like normal, by the way. So, atmospheric protection. The ozone layer. In the stratosphere, the ozone layer absorbs the sun's UVB radiation and prevents it from reaching Earth and causing skin damage. Greenhouse effect. Gases like CO2 trap heat from the sun, maintaining a stable temperature on Earth. These greenhouse gases provide perfect conditions for life. Pressure regulation. The atmosphere creates air pressure, crucial for the existence of liquid water. Meteorite production. Friction with air molecules causes objects entering the atmosphere to heat up and disintegrate before reaching the ground. So, this is essentially the greenhouse effect. So, solar radiation from the sun enters. Some of it is reflected off by the atmosphere and the earth, while some of it is absorbed or re-emitted by the infrared by the greenhouse gas molecules around the atmosphere, which essentially heats up the world and helps the heat be maintained across Earth. Now let's talk about the ozone layer. The ozone layer is in, as you remember over here, it's in the stratosphere. So the ozone layer protects life on Earth by absorbing ultraviolet B radiation from the sun. When the ozone layer is depleted, more of this UVB radiation reaches Earth's surface, which can have harmful effects on human health and the environment. More exposure to UVB radiation can cause skin cancer, cataract, and damage to the immune system, causing premature aging of the skin. In the environment, UVB radiation can damage crops, marine organisms, and other materials. It can disrupt biological processes in plants, such as how nutrients are distributed and when developmental phases occur. And these changes can impact plant competitive balance, herbivory, and plant diseases. Finally, marine ecosystems. UVB radiation can damage the early developmental stages of fish, shrimp, crab, amphibians, and other marine animals, and they can reduce the survival rate of phytoplankton, which form the foundation of aquatic food webs, which can essentially destroy food webs in the marine ecosystems. The ozone layer is located in the stratosphere 15 to 30 kilometers above the Earth's surface. The pollution of the ozone layer is due to industrially produced substances like chlorofluorocarbons found in spray cans, refrigerators, and the air conditioners. These were effectively banned from the Montreal Protocol, as a fun fact. The ozone hole. As you heard about the ozone layer in the stratosphere, let's talk about the ozone hole, which is around. Now let's talk about the ozone hole, and we'll talk about where exactly it forms. The ozone hole is a seasonal thinning of ozone layer in each spring in Antarctica, and it's from a combination of ozone depleting substances, sunlight, polar stratospheric clouds, and the polar vortex. So in the late summer, talking about how it forms, the southern hemisphere receives solar radiation, while the polar vortex keeps air masses isolated, and this creates conditions favoring ozone depletion. When sunlight returns in October, chlorine atoms are released into the stratosphere, destroying ozone molecules. So, how does this ozone hole actually close? In November and December, the temperatures in the southern stratosphere start to increase, and the polar vortex breaks up, effectively removing this ozone hole. Now let's talk about something that isn't so annually, something that changes annually, the Australian ozone layer. The ozone layer over Australia has been thinning since the 1960s, and the country has been a leader in phasing out ozone depleting substances. However, the ozone layer has been further damaged by the numerous wildfires in Australia, and climate change is causing more wildfires in the future, which will thin the ozone layer even more. This is leading to more radiation, and due to the less melanin, it's leading to the higher prevalence of skin cancer. Okay, now let's talk about another main constituent of the atmosphere, the actual air composition. Most of the air, as you can see, is 78% nitrogen and 21% oxygen. So 99% of the air is just from these two. Argon is around 0.93, while carbon dioxide is around 0.03%. And the rest of these gases are trace gases in the atmosphere. Uh, so now let's talk about the natural GHGs, or greenhouse gases. CO2 is released from volcanic eruptions in the decomposition of organic matter and cellular respiration from plants and animals. Methane, or CH4, is emitted from natural wetlands, rice paddies, and animal digestion. N2O or nitrous oxide is produced naturally in soil by microbial processes. Water vapor H2O is naturally occurring in the atmosphere and is influenced by weather patterns. So these natural GHGs are emitted by natural causes, and the human activities significantly increase their concentrations in the atmosphere, causing climate change as well. Now let's talk about anthropogenic GHGs. So breaking up the word anthropogenic. Anthro means humans, so therefore anthropogenic means it's caused by humans. Okay, CO2. It's primarily from burning fossil fuels, coal, oil, or natural gas for electricity generation, transportation, and industrial processes, as well as deforestation. CH4 methane is from livestock farming, landfills, natural gas production, and distribution leaks. N2O, nitrous oxide, is from agriculture practices like fertilizers. And fluorinated gases, which mean they have fluorine in it, HFCs, PFCs, SF6. They are all synthetic gases used in refrigeration, air conditioning, and industrial processes. The main source of anthropogenic greenhouse gas emissions is the burning of fossil fuels. So agriculture plays a significant role in emitting methane and nitrous oxide. So overall, agriculture is the main constituent of these gases. Synthetic greenhouse gases like CFCs or chlorofluorocarbons are entirely human-made and highly impact the world through climate change. Now let's talk about natural anthropogenic sulfur compounds. Natural sources. Volcanic eruptions are the natural source of sulfur dioxide, SO2, releasing huge amounts of sulfur into the atmosphere when they erupt. Anthropogenic is when burning of fossil fuels occurs, such as coal, and this leads to a major source of sulfur dioxide emissions from plants and industrial facilities. Chemical transformations occur when sulfur dioxide enters the atmosphere, reacting with water and oxygen to form sulfuric acid, condensing into tiny sulfur aerosols. Cooling effect. Sulfur aerosols reflect sunlight back into space, creating a cooling effect on the planet and decreasing the greenhouse effect. Regional impacts. Depending on wind patterns, areas with high sulfur emissions can experience significant acid rain, which can damage forests, aquatic ecosystems, and buildings. Finally, sulfur dioxide as a whole. It's a major pollutant from volcanoes and anthropogenically from fossil fuels. H2S, hydrogen sulfide, is a foul smelling gas from natural sources like decaying organic matter. Dimethyl sulfide is a volatile, which means alkali gas, organic sulfur compound produced by marine phytoplankton, and sulfates form in the atmosphere from the oxidation of sulfur dioxide, contributing to acid rain. So now let's talk about black carbon aerosols or soot. So black carbon is a type of atmospheric particulate matter absorbing light and can contribute to climate change and other environmental or health issues. So climate change. BC aerosols are a major contributor to climate change warming and melting of snow and ice in the Arctic. BC or black carbon absorbs visible and infrared radiation, heating up the atmosphere and darkening surfaces. So this can harm ecosystems and vegetation and can cause harmful effects on the cardiovascular system, heart, and lungs, the, and the respiratory diseases. Sources. Black carbon aerosols are emitted from the incomplete combustion of fossil fuels and biomass from diesel engines, wildfires, and other sources. The lifetime. Black carbon aerosols are removed from the atmosphere in 1 to 2 weeks, so the impacts are much more regional than global. Okay, so finally, this is the last topic, volcanic particulates. They form, they're primarily sulfur dioxide gas released during volcanic eruptions and can significantly impact the climate by forming aerosols in the stratosphere. The stratospheric impact. The most impactful volcanic aerosols reach the stratosphere where they can remain for extended periods due to the stable atmospheric conditions. Large eruption effects, major volcanic eruptions like Mount Pinatubo, 1991, or Mount Tambora, 1815, can cause noticeable global cooling for several years following the eruption. Limited duration. Unlike greenhouse gases from human activities, the cooling effect from volcanic aerosols lasts for a few years until the particles are naturally removed from the atmosphere. Ozone depletion. Volcanic aerosols can also contribute to ozone depletion by preventing surfaces for chemical reactions that break down ozone molecules. Regional variations. Depending on wind patterns, the cooling effect from volcanic aerosols can be more pronounced in certain regions of the world. Volcanic dioxide release. Carbon dioxide releases. While the cooling effect of the volcanic aerosols is dominant, volcanic eruptions can release carbon dioxide, a type of greenhouse gas, which contributes to long-term warming. Okay, so now let's talk about the homework. I know some people have done it, but not everyone has done it. So make sure to review this whole recording, all of these slides, make them into notes, and research much, much more. Continue to have your notes 3 and onwards, and the competition is this Saturday. So make sure you have all of it done. This um this slide is a bit outdated, but since invitation was a few days later, make sure to send your entire binder to us so we can review it. And your homework, even though it says by the next mentoring session, which will be in a few days, please send your notes to us ASAP to both of these emails. Also, uh, uh, since Bottle Invitational is coming up soon, I have a few tips and advices. So, one, while you may have your notes and everything, please remember to memorize some of the most important stuff. Since you have a big binder, it's going to be hard to navigate all of it in just simply 50 minutes, and there's a lot of questions. So, make sure you know the basis of how it is, and make sure to memorize some parts. Use acronyms or and you can also use like acronyms to like memorize stuff like the layers of the earth, like T TSMS TSM TSMTE. You can just have that and like try to memorize that to know the layers quickly, as most likely that will be a question on the test. Just be like layers of the earth. On top of that, please make your binders organized so that you can easily go through it in the competition. That'll help and save a lot of time. But overall, please review all of these slides and good luck.